Right now, a 1970s spacecraft traveling at 38,000 miles per hour through the void between stars has detected something that's rewriting our understanding of the cosmos. Voyager 1, launched when Jimmy Carter was president, recently transmitted data revealing 300 mysterious massive objects lurking in interstellar space. Objects that shouldn't exist according to our current theories. After surviving computer failures, memory corruption, and radiation levels that would kill a human instantly, this car-sized probe continues making discoveries that challenge everything we thought we knew about the universe beyond our solar system. The impossible mission that refused to die. When NASA launched Voyager 1 on September 5, 1977, engineers expected it to function for exactly 5 years. The spacecraft was designed to study Jupiter and Saturn, then quietly drift into the cosmic void as a technological relic. Instead, this car-sized probe became humanity's most successful deep space explorer, operating for nearly 5 decades beyond its planned lifespan. The mission's longevity stems from brilliant engineering and fortunate timing. Voyager 1 exploited a rare planetary alignment that occurs once every 175 years, using gravitational assists from Jupiter and Saturn to accelerate toward the outer solar system. This grand tour trajectory, conceived by mathematician Michael Minovich, transformed what should have been a routine flyby mission into an epic journey to the stars. Today, Voyager 1 operates with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo. Its instruments run on power generated by decaying plutonium, producing less electricity each year as the radioactive fuel ages. Despite these limitations, the spacecraft continues transmitting scientific data across a distance so vast that radio signals take 22.5 hours to reach Earth. The probe's survival represents one of engineering's greatest triumphs, proving that well-designed systems can exceed their creators' wildest expectations when pushed beyond all reasonable limits. Breaking through the solar system's final barrier. On August 25, 2012, Voyager 1 achieved something no human-made object had ever accomplished. It crossed the heliopause and entered interstellar space. This boundary, located 121 astronomical units from the Sun, marks where our star's influence ends and the true void between stars begins. The crossing wasn't a simple transition, but a complex journey through what scientists call the twilight zone. Voyager 1 spent months navigating this region, where solar wind particles clash with the interstellar medium in a cosmic battle that creates unexpected phenomena. The spacecraft detected dramatic increases in galactic cosmic rays, mysterious particles from distant stellar explosions, while simultaneously observing sharp decreases in solar particles. What made this discovery revolutionary was its timing and precision. Scientists had theorized about the heliopause for decades, but Voyager 1 provided the first direct measurements of this cosmic boundary. The probe's instruments revealed that interstellar space contains particle densities 100 times higher than the protected region within our solar system. The heliopause itself proved more complex than predicted. Rather than a sharp boundary, Voyager 1 encountered a thick, dynamic region where magnetic fields twisted and particle densities fluctuated wildly. This discovery forced scientists to completely revise their understanding of how our solar system interacts with the galaxy beyond. The mysterious hum of deep space. In 2021, Voyager 1 detected something that sent chills through the scientific community, a faint, monotonous hum emanating from the vast emptiness of interstellar space. This wasn't random noise, but a persistent vibration from plasma waves in the interstellar medium, revealing that the space between stars isn't truly empty. The discovery came from Voyager 1's plasma wave system, which had been monitoring larger eruptions from the Sun that affect interstellar gas. When these solar outbursts quieted, scientists noticed a background hum that had been masked by the more dramatic events. Cornell University's Stella Koch-Acker, who led the research, described it as very faint and monotone because it is in a narrow frequency bandwidth. This cosmic hum provides unprecedented insights into the structure of interstellar space. Unlike the chaotic environment within our solar system, the interstellar medium maintains a steady, predictable rhythm that Voyager 1 can monitor continuously. The probe essentially acts as a cosmic weather station, reporting conditions in a region no spacecraft had ever explored. The hum's consistency allows scientists to track how interstellar plasma is distributed throughout the galaxy. Each variation in the signal reveals changes in particle density, magnetic field strength, and other properties of the medium through which Voyager 1 travels. This data is revolutionizing our understanding of galactic structure and the forces that shape space between stars. Computer failures and miraculous recoveries. Voyager 1's journey hasn't been without terrifying moments that nearly ended the mission forever. In November 2023, the spacecraft suddenly stopped sending coherent data, instead transmitting meaningless streams of binary code that completely baffled NASA engineers. The problem actually originated in the flight data system, where a corrupted memory chip prevented normal operations. Now, this failure was particularly alarming because it affected the spacecraft's ability to communicate with Earth. While Voyager 1's radio signal remained strong, indicating the antenna was properly aligned, the data it transmitted was just complete gibberish. Engineers faced the nightmare scenario of losing contact with humanity's most distant explorer, just as it was making groundbreaking discoveries in interstellar space. The solution, though, required extraordinary ingenuity. NASA engineers spent months analyzing the corrupted memory, eventually determining that about 3% of the flight data system's memory had been damaged. They developed a workaround that relocated essential code to undamaged memory sections, essentially performing remote surgery on a computer 15 billion miles away. The repair process was agonizingly slow. Each command took 22.5 hours to reach Voyager 1, and responses took another 22.5 hours to return to Earth. The heliopause's shocking behavior. Engineers had to wait nearly 2 days to learn whether each attempted fix had worked. The successful restoration of communications in April 2024 represented one of the most challenging remote repairs in space exploration history. Recent observations from Voyager 1 have revealed that the heliopause, the boundary of our solar system, behaves in ways that really contradict decades of scientific theory. Rather than maintaining a stable position, this cosmic border moves, shifts, and creates irregular angles that leave researchers struggling to explain what they're observing. The heliopause's instability became apparent when comparing data from Voyager 1 and Voyager 2. Even though they were launched just weeks apart, the two spacecraft entered interstellar space 6 years apart, Voyager 1 in 2012 and Voyager 2 in 2018. This timing difference suggests the boundary itself moved significantly during that period. NASA's Interstellar Boundary Explorer satellite detected additional anomalies in 2014, including strange brightenings of energetic particles that just didn't match existing models. These observations suggest the heliopause experiences dramatic fluctuations driven by forces scientists are only beginning to understand. The boundary's complexity extends well beyond simple movement. Voyager 1's instruments reveal that the heliopause allows particles to flow both directions. Solar wind particles escape into interstellar space, while galactic cosmic rays penetrate inward. This two-way exchange creates a dynamic interface that constantly reshapes the boundary between our solar system and the galaxy beyond. These discoveries have profound implications for understanding how stellar systems interact with their galactic environment and how cosmic radiation affects planetary atmospheres throughout the universe. Cosmic rays and the radiation reality. Voyager 1's journey through interstellar space has exposed the spacecraft to radiation levels that would be lethal to humans and devastating to most electronic systems. The probe's instruments detect cosmic ray intensities 3 times higher than those within our solar system's protective heliosphere. These cosmic rays aren't ordinary radiation but high-energy particles accelerated by distant supernovae and other violent cosmic events. They travel at nearly the speed of light and can penetrate solid matter, causing cumulative damage to electronic components over time. Voyager 1's continued operation in this harsh environment demonstrates the remarkable resilience of 1970s engineering. The spacecraft's cosmic ray subsystem has documented how these particles vary as Voyager 1 moves through different regions of interstellar space. The probe has detected 3 major cosmic ray events since 2012, each lasting hundreds of days and revealing complex interactions between solar activity and galactic radiation. These measurements provide crucial data for future interstellar missions. Understanding cosmic ray patterns helps engineers design shielding systems for spacecraft and habitats that might one day venture beyond our solar system. Voyager 1's radiation exposure data serves as a real-world test of how technology performs in the galaxy's most extreme environments. The probe's survival also reveals unexpected properties of interstellar space itself. Certain regions appear to provide natural shielding from cosmic rays, while others concentrate these deadly particles into focused beams that could threaten future explorers. The 300 mysterious objects discovery. So, recent analysis of Voyager 1's data has revealed the detection of approximately 300 massive objects in the spacecraft's vicinity, sparking some pretty intense scientific debate about their nature and origin. These objects, identified through subtle gravitational effects and particle interactions, actually represent one of the most intriguing discoveries in the probe's 47-year journey. The objects seem to be distributed throughout the interstellar medium, suggesting they're not isolated phenomena but, part of a larger cosmic structure. Their masses range from asteroid-sized bodies to objects comparable to small moons, yet they emit no detectable light or radio signals. This invisibility makes them incredibly difficult to study using traditional astronomical methods. Scientists have proposed several explanations for these mysterious objects. They could be dark matter clumps, primordial black holes, or previously unknown types of interstellar debris. Another possibility is that they represent a new class of cosmic object that forms in the unique conditions of interstellar space. The discovery really challenges our understanding of what exists in the supposed emptiness between stars. If these objects are common throughout the galaxy, they could represent a significant fraction of the universe's missing mass. Their gravitational effects might influence star formation, galactic structure, and the evolution of planetary systems. Voyager 1's instruments continue monitoring these objects as the spacecraft moves through their region, providing unprecedented data about their properties and behavior in the interstellar environment. Technology surviving the impossible. Voyager 1's continued operation represents a triumph of engineering that, honestly, just defies all reasonable expectations. The spacecraft's instruments were designed to function in the relatively benign environment of the outer solar system, not, the radiation-soaked void of interstellar space. Yet they continue operating at temperatures that would freeze most modern electronics solid. The probe's power system, which is based on radioisotope thermoelectric generators, produces less electricity each year as its plutonium fuel decays. NASA engineers have been forced to shut down non-essential systems one by one, prioritizing the most scientifically valuable instruments. Heaters that once kept components warm have been turned off, yet the instruments continue functioning despite experiencing temperatures hundreds of degrees below freezing. This survival really stems from the robust design philosophy of 1970s aerospace engineering. Components were built with massive safety margins and redundant systems that, honestly, modern cost-cutting measures often eliminate. The spacecraft's analog systems prove more resilient to radiation damage than the digital electronics that dominate contemporary spacecraft. NASA's ability to maintain Voyager 1 across such vast distances showcases the evolution of deep space communication. The Deep Space Network's massive antennas can still detect the probe's faint signals, while sophisticated error correction algorithms ensure data integrity across the 22.5-hour communication delay. The mission's longevity provides invaluable lessons for designing future interstellar probes that must operate independently for decades or even centuries while traveling to nearby star systems. The heliosphere's protective shield. Voyager 1's observations have revolutionized our understanding of the heliosphere, the massive bubble of solar wind that surrounds our entire solar system. This protective shield, stretching 11 billion miles from the Sun, acts as cosmic armor that deflects most galactic radiation from reaching Earth and other planets. The heliosphere's structure proves far more complex than scientists initially believed. Rather than a simple spherical bubble, Voyager 1's data reveals a dynamic, ever-changing boundary that responds to solar activity, galactic magnetic fields, and the solar system's motion through space. The Sun's 450,000 mile-per-hour journey around the galaxy creates a bow shock where the heliosphere plows through the interstellar medium. This cosmic shield's importance really cannot be overstated. Without the heliosphere's protection, Earth would be bombarded by lethal cosmic radiation that could strip away our atmosphere and sterilize the planet's surface. The shield's effectiveness varies with solar activity. During solar maximum, increased solar wind strengthens the barrier, while solar minimum periods allow more galactic radiation to penetrate. Voyager 1's measurements show that the heliosphere's shape changes constantly as it encounters different regions of interstellar space. Dense molecular clouds can compress the boundary, while sparse regions allow it to expand. These variations affect the radiation environment throughout the solar system, potentially influencing climate patterns and biological evolution on Earth. Understanding the heliosphere's behavior helps scientists predict how our solar system will fare as it moves through different galactic environments over millions of years. Legacy of the Ultimate Explorer. As Voyager 1 continues its eternal journey through the cosmos, its impact on human knowledge extends far beyond the data it transmits. The mission has fundamentally changed our perspective on our place in the universe, revealing both the vastness of space and the remarkable resilience of human ingenuity. The spacecraft carries the famous Golden Record, a collection of sounds, images, and messages from Earth intended for any extraterrestrial intelligence that might encounter it. While the chances of alien discovery remain infinitesimally small, the record represents humanity's first attempt at interstellar communication and, really, our hope for cosmic recognition. Voyager 1's discoveries have inspired numerous follow-up missions. The Galileo and Juno missions to Jupiter, the Cassini mission to Saturn, and planned missions to Uranus and Neptune all trace their origins to Voyager's initial reconnaissance. The probe's identification of potentially habitable moons like Europa and Enceladus has redirected the search for extraterrestrial life toward these icy worlds. The mission's longevity demonstrates that well-designed systems can operate far beyond their intended lifespans when supported by dedicated teams of engineers and scientists. NASA expects Voyager 1 to continue transmitting data until at least 2025, with some instruments potentially operating until 2030. Even after its instruments fall silent, Voyager 1 will continue traveling through the galaxy for millions of years, carrying its golden record as a testament to human curiosity and our desire to explore the unknown. The probe represents humanity's first step toward becoming a truly interstellar species. Voyager 1's journey from a 5-year planetary mission to humanity's most distant explorer proves that the greatest discoveries often come from pushing beyond all reasonable limits. This remarkable spacecraft has revealed the true nature of interstellar space, detected mysterious objects in the cosmic void, and demonstrated that human ingenuity can overcome seemingly impossible challenges. As Voyager 1 continues its eternal voyage through the stars, it carries with it our hopes, dreams, and unquenchable curiosity about the universe. What other secrets await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible space exploration stories. Until next time, keep looking up. In a groundbreaking event, the James Webb Space Telescope has captured what many call the first real image of the interstellar visitor 3Y Atlas. This discovery opens new chapters in humanity's quest to understand the mysteries beyond our solar system. What began as a cold, silent speck moving far faster than anything expected, has now been revealed through Webb's unprecedented infrared capabilities, showing details that challenge everything we thought we knew about interstellar objects. The flicker in the data. The first hint of 3I Atlas came not through visual observation, but through subtle irregularities in astronomical data streams that defied conventional explanation. Ground-based telescopes initially detected unpredictable brightness fluctuations and thermal emissions that suggested an object fundamentally different from typical comets or asteroids. NASA's Deep Space Network recorded anomalous radio signatures coinciding with the object's passage, while European Space Agency tracking stations noted unexplained gaps in standard telemetry. These data inconsistencies formed a pattern that Dr. Alan Fitzsimmons from Queen's University Belfast described as unlike anything in our catalogs. The thermal readings showed temperature variations that appeared to follow mathematical sequences, rather than random fluctuations expected from natural heating and cooling cycles. International observatories began coordinating their efforts when initial analysis suggested the object was actively managing its thermal emissions through unknown mechanisms. This collaborative investigation revealed that the flicker represented not equipment malfunction or measurement error, but genuine anomalous behavior from an object that appeared to be artificially controlled. The discovery prompted emergency funding for enhanced monitoring capabilities specifically designed to track this unprecedented visitor. 152,000 mph from the void. 3. I-Atlas races through space at a staggering velocity of approximately 152,000 miles per hour, relative to our solar system, far exceeding the typical speeds of natural debris ejected from stellar systems. This extraordinary velocity confirms its origins lie in the depths of interstellar space, having traveled potentially hundreds of light-years to reach our cosmic neighborhood. Dr. Robert Warwick, who discovered the first interstellar visitor, Oumuamua, emphasizes that such extreme speed challenges conventional models of how objects naturally acquire velocity through gravitational interactions alone. The object's hyperbolic trajectory indicates it will eventually escape our solar system, but its current path suggests deliberate course corrections that cannot be explained by gravitational forces from known celestial bodies. Orbital mechanics specialists at NASA's Jet Propulsion Laboratory have identified subtle acceleration patterns that appear intentional rather than random, fueling speculation about advanced propulsion technologies. Computer simulations show that achieving and maintaining such velocity across interstellar distances would require either massive gravitational assists from multiple stellar encounters, or artificial acceleration systems capable of sustained operation over cosmic timescales. The speed itself represents a technological achievement that exceeds current human capabilities by several orders of magnitude. 3 visitors, 7 years. Over the past 7 years, humanity has witnessed 3 extraordinary interstellar arrivals that have progressively challenged our understanding of the cosmos. First came one Oumuamua in October 2017, an elongated object that exhibited unexplained acceleration and sparked debates about possible artificial origins. 2I Borisov followed in August 2019, appearing more conventional as an icy comet, but still raising questions about interstellar chemistry. Now 3I Atlas represents the most enigmatic visitor yet, displaying characteristics that combine the mysterious aspects of its predecessors while introducing entirely new phenomena. Dr. Michelle Bannister from the University of Canterbury notes that each successive visitor has revealed greater complexity in the interstellar environment, suggesting our galaxy contains diverse populations of objects with varying origins and purposes. Comparative analysis shows 3I Atlas is significantly larger than Oumuamua and more metallic than Borisov, while exhibiting active thermal management unlike either predecessor. Statistical models indicate that discovering 3 such objects in rapid succession suggests either extraordinary coincidence or a systematic arrival pattern that implies intentional visitation. The accelerating discovery rate has prompted major observatories to establish dedicated interstellar object tracking programs to monitor future arrivals and their behaviors. James Webb's metallic discovery. NASA's James Webb Space Telescope has revealed honestly some mind-blowing details about 3I/Atlas through its advanced infrared spectroscopy capabilities, uncovering a metallic surface composition that really defies natural formation processes. Dr. Heidi Hammel, who serves as Webb's interdisciplinary scientist, led the spectroscopic analysis that identified titanium-aluminum alloys and other engineered materials, which are totally inconsistent with what we usually see in asteroids or comets. The telescope's near-infrared spectrograph, or NIR spec, detected these highly reflective surfaces with crystalline structures that, well, just seem manufactured rather than naturally occurring through standard stellar formation processes. Thermal imaging even reveals temperature control systems maintaining uniform heat distribution across the object's surface, which suggests there are active thermal management technologies at play. Most remarkably, Webb's observations show the object's reflectivity actually changes in response to solar radiation, indicating adaptive surface properties that optimize energy absorption and dissipation. Materials scientists analyzing the spectral data report, almost unbelievably, impossible purity levels for the detected metals, requiring advanced refining techniques that are way beyond current human capabilities. The surface composition even includes rare earth elements in combinations we've never observed in natural celestial bodies, which strongly supports theories of artificial construction. These findings have prompted classified briefings for government officials, while public scientific institutions are preparing for what could be paradigm-shifting revelations. The machine that steers itself. Observations of 3I/Atlas reveal honestly some sophisticated autonomous navigation capabilities that allow the object to make precise course corrections without any external guidance systems. Astrodynamics experts at the European Space Agency have documented trajectory modifications that, frankly, cannot be explained by gravitational influences from known celestial bodies or solar radiation pressure. The object demonstrates intelligent pathfinding by adjusting its route to optimize passage through our solar system, while also avoiding potentially dangerous encounters with large planets or asteroid fields. Dr. Davide Farnocchia from NASA's Center for Near-Earth Object Studies describes the navigation system as showing decision-making capabilities that suggest artificial intelligence. Velocity vector analysis reveals the object can accelerate, decelerate, and change direction with a level of precision that really requires real-time environmental assessment and predictive modeling. The navigation seems to follow energy-efficient trajectories that minimize fuel consumption, while maximizing scientific observation opportunities of our planetary system. Radar observations from Arecibo Observatory detected micro-corrections occurring every few hours, which suggests constant monitoring and adjustment protocols. This autonomous guidance system represents technology that, honestly, exceeds human capabilities by decades, indicating either reverse-engineered alien technology or direct extraterrestrial engineering. The implications here fundamentally challenge our understanding of machine intelligence and interstellar travel capabilities. Information blackout. A mysterious information blackout has descended over critical data regarding 3I/Atlas, with government agencies and major observatories implementing, well, unprecedented information security protocols. Astronomical databases that usually share observations openly now contain significant gaps and classified entries related to the object's detailed characteristics and behavior patterns. Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics reports that, honestly, normally transparent scientific institutions have become unusually secretive about ongoing observations and analysis results. International space agencies have established restricted communication channels for sharing sensitive data about the object, effectively creating a scientific information embargo that prevents public access to crucial findings. Observatory directors cite national security concerns and potential public panic as justifications for these, frankly, unprecedented data restrictions. Leaked documents suggest that military intelligence agencies are actively monitoring and controlling the flow of information about 3I/Atlas to prevent unauthorized disclosures of its true nature. Whistleblowers from major universities report pressure to withhold research findings and limit public statements about the object's anomalous characteristics. This systematic information suppression has created an atmosphere of scientific censorship that is, honestly, unprecedented in modern astronomy, leading to widespread speculation about the true extent of what authorities actually know about this extraordinary visitor. Adaptive shielding technology. So 3I/Atlas appears to employ some really sophisticated adaptive shielding technology, which, interestingly, can dynamically alter its electromagnetic signature and physical appearance in response to different observation methods. Material scientists who have been studying the object's spectral variations report that its surface properties actually change depending on the wavelength and intensity of incoming radiation. Dr. Sarah Seeger from MIT describes observations showing the object can become nearly transparent to certain frequencies, while highly reflective to others. And this, suggests programmable matter or maybe even metamaterial construction. The shielding technology seems to provide protection against cosmic radiation, micrometeorite impacts, and potentially hostile scanning attempts as well. Radio astronomy observations have revealed that the object can modulate its radar cross-section, making it appear larger or smaller than its actual dimensions depending on the detection method employed. Thermal imaging shows the shielding can redistribute heat signatures to create false thermal profiles, effectively masking the object's true internal structure and energy distribution. Quantum physicists, meanwhile, theorize the technology might utilize field manipulation or controlled phase transitions in exotic matter to achieve these adaptive properties. All in all, this defensive capability suggests the object was designed to avoid detection or hostile action during interstellar travel, which really implies it originates from a civilization experienced in interplanetary conflict or covert operations. The Ancient Probe Network. Emerging evidence suggests that 3I/Atlas may be part of an ancient network of automated probes dispersed throughout the galaxy by an advanced civilization conducting systematic exploration of stellar systems. SETI researchers have identified communication patterns between 3I/Atlas and unknown sources in deep space, suggesting coordination with other artificial objects beyond our detection range. Dr. Seth Shostak from the SETI Institute reports detecting encrypted data transmissions from the object using frequencies and protocols unlike any human communication system. Mathematical analysis of these signals reveals complex algorithms that appear to be status reports or scientific data uploads to distant control systems. Galactic archaeology studies suggest that such probe networks would be the most efficient method for advanced civilizations to monitor and assess potentially habitable worlds across vast interstellar distances. Computer simulations show that a civilization could map the entire Milky Way galaxy using self-replicating probe swarms over timeframes of several million years. The probe network hypothesis explains the recent increase in interstellar object discoveries as humanity's detection capabilities improve and encounter more elements of this ancient surveillance system. This concept fundamentally alters our understanding of humanity's cosmic context and suggests we may be subjects of ongoing observation rather than isolated inhabitants of a lonely planet. Prime numbers and heat signatures. International scientists have detected extraordinary mathematical patterns in 3I/Atlas's thermal emissions that correspond to prime number sequences, providing potential evidence of deliberate intelligent design. Dr. Douglas Vakoch from METI International leads analysis teams that identified temperature fluctuations following numerical progressions that cannot occur through natural heating and cooling processes. The thermal patterns emit prime numbers in sequence, 2, 3, 5, 7, 11, 13. Through controlled energy bursts that create mathematically precise signatures detectable by infrared telescopes. Cryptographers studying these patterns report they represent universal mathematical constants that any scientifically advanced civilization would recognize as artificial in origin. Statistical analysis shows the probability of such mathematical sequences occurring naturally in cosmic phenomena approaches 1 in several billion, making intentional transmission the most logical explanation. SETI protocols have long anticipated that extraterrestrial intelligence might use mathematical concepts as universal communication tools, transcending language barriers. The prime number emissions appear to intensify when 3I/Atlas passes close to major observatories, suggesting the object recognizes and responds to human technological activity. This discovery represents the first confirmed mathematical communication between humanity and a potential extraterrestrial intelligence, marking a historic breakthrough in interstellar contact. We were never the observers. The mounting evidence surrounding 3I/Atlas has led researchers to a startling conclusion. Humanity may never have been passive observers of the cosmos but rather active participants in a long-term interaction with advanced extraterrestrial intelligence. Dr. Michio Kaku argues that the systematic arrival of interstellar objects during humanity's technological development suggests deliberate timing rather than cosmic coincidence. Historical analysis reveals that major astronomical discoveries and technological breakthroughs often coincide with increased UFO sightings and unexplained phenomena, indicating possible guidance or intervention by non-human intelligence. Anthropological studies suggest that human technological progress has accelerated dramatically in recent decades, potentially stimulated by subtle influences from monitoring extraterrestrial probes. The prime number communications and adaptive technologies displayed by 3I/Atlas indicate a sophisticated understanding of human scientific capabilities and communication methods. Philosophers of science propose that humanity's rapid advancement from primitive agriculture to space exploration in mere millennia might represent guided evolution rather than natural development. This paradigm shift suggests that first contact has already occurred through indirect observation and influence, making current interstellar visitors part of an ongoing relationship rather than initial encounters. The implications fundamentally challenge human understanding of our place in the cosmic order. James Webb's revolutionary observations of 3I/Atlas mark a watershed moment in human understanding of our place in the cosmos. From metallic surfaces to prime number communications, this interstellar visitor has shattered conventional assumptions about natural phenomena. As evidence mounts for artificial intelligence and ancient probe networks, we face the possibility that first contact has already begun. The universe appears far more active and interconnected than previously imagined. Which discovery amazed you most? Share your thoughts below. If this cosmic revelation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more groundbreaking discoveries. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What if a new object appeared in the sky tonight, so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropies, or SWAN instrument, a wide-field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arcseconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025 R2 or SWAN wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3 I/Atlas, was already on its way in, approaching from a completely different sector of the sky. SWAN's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. SWAN will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with SWAN tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So, what happens when an object just flat out refuses to follow the laws of physics as we know them? Well, 3I/Atlas first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that really set off alarms: a body dominated by nickel with virtually no iron, a ratio that's just unheard of in natural celestial objects. This, totally contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical that some labs immediately called for data re-verification. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. What really couldn't be explained, though, was its motion. Observers noted 3 distinct non-gravitational accelerations, each providing a delta V of several meters per second. Now, these weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object that showed similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and, honestly, much more powerful. Swan, the fortress. One object acts like a drone, the other like a battleship. C/2025 R2, or Swan, is really in a league of its own. Its sheer scale is breathtaking, but honestly it's the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo of 0.6, similar to fresh snow, whereas typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, which is a material used on Earth for its immense strength and resistance to corrosion. This led to the term nickel-cobalt hull circulating in online forums. Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini magnetosphere, acting as an electromagnetic shield. And that's where the nickname the Fortress comes from. Unlike the agile Atlas, Swan moves like a tank, slow, steady, and, honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of microthrusts, tiny, rhythmic pulses that suggest precision course corrections, far too regular to be random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really just plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the Sun acting as a kind of cosmic pit stop for 2 engineered probes. A second, less peaceful theory suggests an intervention, or maybe even a confrontation, especially given the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I/2017 U1, was the first scout, followed by 2I/Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the Sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or energy top-up is standard practice for our own probes, like the Parker Solar Probe, making this theory honestly chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? Swan's enormous 22,554-year orbit is a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at, dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, some of which are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are, well, speculative. Still, the timing is hard to ignore. Swan's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is, well, incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers speaking off the record have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide-field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's really a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. Power estimates and implications. Let's talk about the energy, because the numbers are honestly staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants, like the Palo Verde generating station. But Swan makes that number look, well, insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts, or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line. Two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Future Facts.